Hello guys, welcome back to the Science for Kids channel. Today we're talking about titration. But without any further ado, let's jump right in. Well, you must be wondering what this word titration actually means. Actually, just a common laboratory method of determining how much something is inside a solution. Let's say you have an unknown amount of cereal in a bowl, and you have this weird urge to just know how much cereal is inside that bowl. Anyways, what you do know is that you have 1 part of cereal for every 2 parts of milk. And because you want to make a perfect cereal breakfast. And you have a superpower that lets you know the ratio without counting anything. So we pour milk into our bowl until we reach our perfect ratio. Then we look into our container and see how much milk has been removed. We can then detect that it only has 20 parts of milk. So that means that we have used 20 parts of milk. That must mean that we have 10 parts of cereal. That is a titration. Not so hard, is it? Now let me show you what we can actually do in a lab without cereal. Alright, so now we have HCl in this beaker and NaOH in this one. So with this droppy thing, I'm going to get some HCl. To be precise, 2 squirts. And using a different dropper for, many reasons, we're going to put this one into here. But we do it twice. So we're going to keep them separate. However, we can tell the difference with something called an indicator, which will be this thing, phenolphthalein. Alright, now, so I have just magically summoned a 3rd dropper. And this is called a phenolphthalein solution, like I mentioned earlier. And it may sound very weird. Trust me, it is. It's just an indicator, and you'll find out later why it's called an indicator. Alright, so now we're going to use this indicator and pour 2 drops into each. So I added 2 squirts into this one. Nothing happened. But I added 1 squirt and a color change occurred. Wow, so cool, right? We'll really be shocked. You'll never know that this actually happened. Wow. So with this phenolphthalein solution, we can help identify the difference between an acid or a base. This will be an acid, this will be a base. Oops, I spilled some. Okay, but if I get some acid from this one and pour it back into this one, nothing happens yet. But if I do it again, as you can see, we actually pour the acid back into the base. We neutralize it. So now we have this little milky white thing. So I'm going to assign you guys a scenario where there has just been a chemical disaster that we caused, and we are going to fix it now. We just found out that a chemical factory has poured chemicals into a stream, and we must save them from impending doom. What we're going to do is find out how much acid has been poured into the stream. So here we have totally undrinkable stream water. We're going to find out how much acid is inside this stream water. Alright, so we're going to find out how much acid is inside this sample of river water. So now we're going to carefully pour 50 milliliters of this thing into this thing. So, perfect. Exactly 50 milliliters. Now I'm going to transfer the contents into this plastic thing by pouring it. There, all done. Okay, I'm going to pour this into the top. So, firstly, we need to pour phenolphthalein into my acid. Now we have our acid with our indicator. We'll put this right under there. And then now we can begin our titration, yes. Okay, so first of all, we need to make sure our thing is steady. If not, you can adjust it. We can pour it in like you would do with a tap. And we carefully. So we're going to keep adding in. But we want it to stay purple because it looks cool. We're getting closer, so we'll have to add it a bit slower. Now we shake again. We have to make sure we get the sweet spot. There, this is what it looked promising, but unfortunately, it was almost enough. It's pink now. Now we're going to turn this around and read the reading on our burette. 24.1. Next, we're going to do your least favorite subject, math. So we're going to go to the classroom. So here is our equation for the reaction we've just done. As you can see, 1 mole of acid reacts with 1 mole of base. So to calculate the concentration, we have to use this formula. N equals C times V, where N is the number of moles, C is the concentration, and V is the velocity. So, looking at the model of the sodium hydroxide we used, we can see the concentration, which would be 0.1 moles per liter. That will be the concentration. So, 0.1 multiplied by the volume, which was 0.024, that gives us a grand total of 0.0024 moles. From this, we must know that we have used the exact same amount of moles from the acid. However, the volume will be different. So, we swiftly rearrange the equation like this, and then we have moles divided by volume, which is 50. Therefore, our concentration must equal 0.0024 divided by 0.5, which, using simple math, which I'm too lazy to do, so we're going to use a calculator, that gives us 0.048 moles per liter. With this value, we can know what harm this water does to wildlife in the stream. And we also know how much base we should put in to neutralize the acidic stream water. This is why science is so important, guys. So, we're going to end things off by changing the color back because this is a reversible reaction. Well, anyways, I'm going to demonstrate that color change is actually reversible. Yet the reaction isn't. So, as you see, it turned white. So, all you need to do is make it basic, then back to acidic. So, I hope you enjoyed today's video. I hope you found it very useful. And without any further ado, peace. And we're going to carefully pour